We go. Hello and welcome to our April DS Code Pudding live stream. My name is Tiffany Hall. I'm an alumni of TripleTen Software Engineering Program, a full stack engineer and product owner at Scholastic Inc., the world's largest publisher of children's books, and a powerhouse in the digital education space as well. Tonight, I am very excited that I get to be the host of our Code Pudding for our data science students. I'm glad to see that so many of you could join us today, and this Code Pudding is always just a wonderful opportunity for our students all across the US to unite and have fun putting together a project with really stressful timelines. So, what is a Code Jam? So if you're new to this space, a Code Jam is a friendly competition for our students during their normal coursework. They're super short, very compressed timelines where students get together and they kind of jam out a bunch of code. So since ours is a very focused and very tailored part, it's kind of like the pudding, like a dessert, like a nice little end finish. So not quite as broad as a code jam. So that's why we call it a code pudding. Our code pudding consists of two parts: working with the data and building up a model and a presentation. Last week, our participants were divided into teams and were challenged to collaboratively build a model to analyze YouTube comments and predict sentiment polarity. No clue what that is. I'm hoping someone will explain it. The model should classify individual comments as positive or negative and compare the overall sentiment ratio to video's like to dislike ratio to uncover potential discrepancies. Our teams only had 5 days to make their project. And so today, the teams are going to show their projects off to all of you out there. Let's see, our judges next week will be working to evaluate both the model and the presentation. All of our results will be posted on Discord by April 17th. Also, before I forget, there's a really great opportunity for you to vote if you are so inclined to support our audience award winners. So if you are a student of ours, you will be able to vote in the Discord channel. There will be a poll after this presentation. If you're not a student of ours just yet, you can vote on the YouTube comments below this video. You just need to tell us which team you like, and we will tally a vote in their favor. The winners of the audience award will also receive a special prize from TripleTen. I am sure that there will be a hairball from my cat shark bait. So make sure that your favorite team gets that hairball. Okay, just kidding. Now let's go on to presentations. It's my favorite part where we get to see what our teams have worked on and accomplished. So let's wish them good luck. We have two teams this evening. The first team is Rate My Sentiments Engine. We have Eric McDougall, Mark Luff, Rawa Youssef, and Sahini Tamar.
Can you guys see my screen?
Yes, ma'am.
Okay. Hi, everyone. How are you feeling today? So our project is Rate My Sentiments Engine. It is made by initials of our name. The presenters tonight are Rava, Mark, Sohini, and Eric. Rava will take over from here.
Thank you, Sohini. So from here, we started to prepare our data. We merged our data set, the US videos and US comments. Then we started to use our data to work on it, to prepare it for the EDA, like dropping the records with missing malformed data, or remove the duplicates and find the strong engagement signals. And after that, we started to work on the EDA. Usually EDA is the gate that it shows for us when we go in the training model, how it will go. Can you get the next slide, please? So we did many in the EDS, but the most important it was the correlation. And we found in the correlation that we had strong engagement signals found between views, likes, and comments. The correlation was over than or more than 0.6. We had weak features like comment length, category, and data showed little predictive value. The key feature kept views, likes, dislikes, replies, and comment totals all tied to user interaction. Next, please. When you look here, this is the average engagement ratio. So the top engagement makes it really valuable for us to be one of our future for the modeling and analysis. Engagement ratio reflects viewer satisfaction, and this is a big thing that we want because like that we will know if it's positive or negative for our content. And from here, I will let my coworker, as he recorded, Mark, to talk about model training and beta.
Thank you, Rava. So Mark is not there. He will be talking about Vader. Let me start the recording, play the recording, sorry.
In order to accomplish our task, we needed to engineer the sentiment feature into our data. Now, we opted to use Vader, as you can see, which means valence-aware dictionary and sentiment reasoner. This tool provided a negative, neutral, and positive score, as well as a compound composite of the overall sentiment for the full YouTube comment. We looked into using TextBlob and Roberta as well. Now, TextBlob was very easy to use, but when we passed it example strings, it wouldn't always get the correct sentiment. So it seemed like it was going to be ineffective in the full task. We also looked at using Roberta, and honestly, this would have been a great option as well. The main reason why we chose not to use it was because of the amount of time it would take to run, and we had a very short timeline for this overall project. The other reason was because this is a very large data set, and so we thought this was a bit too big for our needs. So as I said earlier, in the end, we chose to use Vader, and it produced a very good result compared to the time it took to implement and run. We were able to use the compound results for building the sentiment target for our machine learning models.
Thank you, Mark. So after doing the Vader part, we started training different models. So we used term frequency inverse document frequency vectorization that helps converting the text data into numerical features, which helps with the machine learning part of it. If you talk about term frequency, it measures the frequency of a term in a document, like how many times it comes in a document. The secondly, inverse document frequency is reducing the weight of the common words, like the words which doesn't need to be required for the sentiment analysis. That's when it reduces the weight for the common words. For the first model, we use natural language toolkit. First of all, what it does, it breaks down, splits the text into words. Then it removes the stop words, which are exactly like a common words. Same thing, the, and, which we don't need for sentiment analysis. Then it performs lemmatization, which means it takes the base root of the word. For example, if you're talking about running and ran, it will fall under run as a same word, and it can do the analysis based on that. The second one was bigram. In there, we picked two consecutive words to analyze the sentiments. And with the combination, we understand what that word means or what sentiment it derives. Sentiment detection, for example, like very good or not very good, something. This model can find the difference between those two. The third we used was bag of words with logistic regression. This is collection of individual text, but it doesn't consider the order of the text. So it has bunch of words together and it derives the sentiment out of that. It is a simple model, but the only thing it doesn't consider the order of it. Thank you. So Eric is our next participant. He's not here, but I will play the video for him as well. Here you go.
I'm Eric. I handled a fair amount of the modeling, and I'm here to talk about the CapBoost classifier and the LightGBM classifier. And these were two particularly useful and powerful gradient boosting algorithms that we used in the course of this project. The cap boost got us to about 88% accuracy. The light GBM got us to, I believe, 91% accuracy on the test set. And these were with regards, and the TF-IDF was mentioned in the slide before as the kind of the vectorization algorithm to turn the comment text into vectors, and allowed the cap boost classifier and the light GBM classifier to work with them effectively. Those were not our best model. It was a logistic regression paired with a bag of words vectorization model. And it got us the best F1 score, AUK score, PRC, with the overall accuracy being around 95% in successfully predicting the polarity of comment text in our training set, and well, in our test set, I mean. So it turned out a more kind of simple simple vectorization algorithm was most appropriate for this machine learning task.
Let Rava will take over from here.
Thank you, Sohail. Thank you, Eric. Now our team went for our conclusion that the best performance model, it would be bag of words plus logistic regression with accuracy 95.7%, and sentiment that was largely independent of views or likes. Most positive sentiment and categories was for movies, entertainment, and how to style people and blogs. The engagement ratio, highest likes to view ratio was for music, comedy, and how to style. The highly sequed most videos received under 1 million with long tail to 20 millions. And this takes us for our recommendation that we had prioritized highest engagement categories like music, entertainment, and how to style, because they were the highest. And the second one, customized moderation by category. For example, comedy and news and politics showed more extreme sentiment. Gaming and tech, they were the lowest. Youth sentiment as a standalone signal. So we need to add this sentiment to engagement model to detect early audience reactions. You have the fourth, enable real-time statement monitoring by deploying live monitoring to flag negative trends or highlight valuable user comments. As the last one, design UX for short, impactful comments. And this will promote users of sentiment-rich input and pin insightful comments to shared tone. From here, I will finish. Thank you for everyone and hope that you enjoyed our presentation.
Thank you so much, guys.
All right. Oh, it was wonderful. I very much appreciate all of the information, but like also what's polarity? Because I'm thinking magnetics.
So polarity is basically understanding the sentiments. So when we use the Vader, we try to figure out with that what is negative, what is positive, and we put numbers to it. For example, 1 was positive, 0 was negative. So it's like polar, where is your mind going? Polarity.
Okay, so it's like the magnet poles. There's positive and negative, but you're assigning a value to the comments to see which one they kind of draw
which one with
to.
like in the comments, if it says like, does it mean positive? Or it was like, but it meant negative, something along those lines. Yeah.
Got it. Okay. So how was it for you guys on this team? I know there's a lot of, obviously there's only 2 of you right here right now, but it's not your first time. So how was it this time?
I let Rava talk about,
Yeah, thank you so much. So for me this time, I was just talking with Sohini before we come that I like that we had different times and each one of us has different jobs, so it was really hard to engagement, but we insisted to keep each one in the loop, and we were updating. And if I can't work, Suhini works. If she can't work, I work, or Mark or Eric, and whatever we finish, we just update the team and we complete from this circle. It was like, for me, like we had this engagement magnetic without to have talking too much, and we finished the mission in my opinion in really nice way. I remember that I had a long day in the work and I couldn't do a lot. So when I came back, Suhini, she made the meeting and she was like, hey, we did 1, 2, 3. So what are you able to do? And I was telling them, hey, I will work at the night to the midnight. So please give me the stuff. And we were like one circle. We didn't feel, we never had one fight until now. And I'm pleased about that because I was worried because we didn't have anyone with experience. So I didn't know how it would go, but in my opinion, it was really good.
Right on. So you guys really turned that time zone thing into a real positive for you guys. Just working around the clock, basically.
It was not even the time zone. People work at different time. There are somebody who's working at night, like Eric works evening, and Mark will work morning, Rava will work, and I'm in events, so I will work whenever. I was like, I'm flexible. Just let me know when you can. I can step out from a meeting and make it happen. So that's what it was. It was not even time zone, but they work in different times. So
Work schedules,
you could just pick up. Yep. So yeah, but it worked out fine. And she's right. We did not fight at once. We were so mature
I love
about
that.
it. Yeah.
It's wonderful.
Yeah.
I mean, not that, but tempers flare when, you've got a short time frame and everyone's trying to live a life and do the things. So that's wonderful to hear.
I think
what was maybe, oh yeah, Raul, go ahead.
I think our teams, each one, he already admitted what is the strength point, and this has made it easier. So I was like, hey, I can work about doing the conclusion, the introduction, and working in the EDA. They were better in the training model. So we weren't competing each other. We have known that our goal to finish this and we can present.
Yeah, so breaking it up, that's really great too.
Yeah.
Fantastic. Well, thank you guys so very much. That is the Rate My Sentiments engine. And that was Eric McDougall, Mark Luff, Rawat Youssef, and Sohini Tamar. Thank you so much. Okay, so our second and last team of the evening is Sentiment Squad. And that is Eli Adams, Alfonso Houston, GL Fadu, and Laura Cofino.
Not all likes are alike. The hidden story is in comments. While like reflects surface level approval, the true sentiment of a video often lies in the comments. To understand this thought, we'll be presenting our YouTube sentiment analysis project by our group Sentiment Squad. Before I start working on our analysis, let me introduce my team. The first one is Eli Adams. He's TripleTen Data Science graduate, followed by myself, Jill Faldu, TripleTen Data Science student, Alfonso Houston, TripleTen Data Scientist graduate, and last, Laura Cofino, TripleTen Data Science graduate. So let's go over a project overview. In this project, we analyzed the sentiment of YouTube comments and compare it to a dislike ratio. The goal was to explore how viewer opinions in comments align or disalign with public engagement. For this, we trained a sentiment classifier to predict if a single comment is positive or negative and use that trained model to estimate the overall sentiment ratio of individual videos. This helped us to answer the key question: does the tone of the comments match the like and dislikes? Based on our project overview, we have 3 big questions. Next slide, please. The first question is, are viewer comments aligned with the like to dislike ratio? Second is, can we train a model to detect sentiment in YouTube comments? Lastly, the third question is, does the predicted comment sentiment ratio reflect public engagement? Based on these big questions, to analyze it, of course, we need a data set. Our data set includes data gathered from videos on YouTube that are contained within the trending category each day. We had 2 data sets comments with 691K rows and 4 columns, which is really big. Then video statistics data set with 7.9K rows and 11 columns. Following this, we did EDA, which is really important part before analyzing anything. So for video data set, we end up cleaning both dataset. For video dataset, we dropped the date column and found no missing values. In the comments dataset, we converted like and replies to numeric data types, removed rows with missing values in comment text, and at the end, we end up cleaning the comments for analysis. For the next slide, as you guys can see, we cleaned and lemmatized the text. Comments include a variety of characters, including punctuation, marks, emojis. So we used a function which is applied to clean and simplify the text. After cleaning the comments, we took an extra step to further simplify the text by applying lemmatization, which reduces each word to its base or root form known as lemma. After cleaning and lemmatizing it, we created a new column which we got by dividing likes by the sum of the dislikes and likes, highlighting videos with high like to dislike ratio. As you guys can see on the graph, the graph is like right skewed distribution, indicating that most videos are well received, which means they have more likes than dislikes. To better understand each data set and their correlation with our question, we did an SDA, statistical data analysis. For this, our first question was, does a higher number of total views on a YouTube video lead to a significantly different like to dislike ratio? And we did a Spearman correlation, which was negative, and a p-value, which was 0.0086. And we found out that we have to reject the null hypothesis. So, although the correlation is statistically significant, it is not practically significant in the real world. The relationship between those two variables exists, but is extremely weak. Then our next question was, does a higher number of total comments on a YouTube video lead to significantly different like to dislike ratio? For this, we found out that the correlation is statistically significant, but it's not practically significant. The relationship between both the variables exists, but is really extremely weak. Going to the third question, does a higher number of total views on a YouTube video lead to a different comment sentiment ratio? For this, we found that the correlation is statistically significant, but there is a moderately negative relationship between those variables. So this result is likely meaningful, but practically and statistically both. Last question, which we did an SDA and help us to understand, was, does a higher number of total comments on a YouTube video lead to different comment sentiment ratio? For this, we found a statistically significant correlation, which is moderately strong negative relation between those two variables. Compared to the above graph, this one is better correlation. So this result is likely meaningful and may have practical and statistical relevance. All these 4 questions end up leading us to the last question, which is our important. Do viewers express different opinions in the comments than they do with dislikes? For this, we found out that likes are just a quick approval, while comments capture deeper sentiment. As you guys can see in the graph, between 0.2 and 0.y on the y-axis, there is where majority of correlation is found with couple outliers. Once our text is clean and ready, we vectorized it using IFIDF, which is term frequency inverse document frequency, and we use the code which you guys can see on the graph on the slide below. Next.
Great. For this point, we only need the target variable that corresponds to a sentiment feature to teach the model if a variable is positive or negative. For example, if a comment says, "This video is amazing," the sentiment is going to be number 1. On the other hand, if they say the terrible audio quality, the sentiment is going to be 0. We do this using TextBlob library, which through a list of words known as good or bad in the English language, you can identify how many of these words are in each comment in the column. We set this in a new column called sentiment label. Then we group and we count how many positive and negative words in a comment has to calculate the sentiment ratio of a comment, and we have our target column.
So in this project, we utilized or trained 4 different classification models. dummy classifier, logistic regression classification model, citizen tree classifier, and light GBM classifier model. Off to the right, you can see this chart. So the metric we use to evaluate the performance of all these models is called the ROC curve. I'm maybe pronouncing that incorrectly, but it essentially measures the general performance of binary classification models. So as you can see, the straight diagonal line is the baseline, which can be used to reference the red, blue, and green lines, which were the other models, the logistic, decision tree, and light GBM. And as you can see, the logistic regression, which is the blue line, performed the best. And after we found out our best model, we produced a comment sample. And as you can see, we have the video ID along with the title and the positive or negative sentiment ratio, which is P&L ratio.
After that, I used this code up here, the top code block, to choose a random video in between 100 comments and 400 comments. So I made sure that there was enough training data for the model itself. I used a sentence transformer to read that video and label each comment based on what we found from TextBlob and seeing if I could train it to quickly give us a response to rate individual comments. I used two pretty obvious ones first, just to make sure it works. So the first text, this video was absolutely amazing and made my day. Obviously, it's positive, and our model was able to see that it's positive. On the other hand, this video was absolutely horrible and ruined my day. The model was able to see that it is definitely negative. Then I tried 5 actual comments. I did go through multiple different variations to find clean ones, but it's really hard because people are really weird. I won't read all of them out loud because some of them are inappropriate, but it was able to relatively do better than I would to rate it on positive or negative, because a lot of comments are pretty vague or sarcastic. And yeah, in conclusion, our initial analysis proved that there is little correlation between comments and the like to dislike ratio. It seems like the majority of people like a video and then ignore, or they comment. It's very, very unlikely that people ever dislike a video. And 2, we were able to predict comments correctly, their polarity. And 3, again, there is no real correlation between even the sentimentality of comments compared to the like and dislike ratio. And that is the end of our project.
I love it. My takeaway from this is definitely that so teens basically nothing matches with what they mean with what they say, since teens are all over YouTube. That is my elder millennial takeaway. All right. No, really great project. I really appreciate you guys showing the different library that you used and the code pieces. That always gets me very excited when I get to see those. Now, you, Eli and Laura, you guys are graduates. How is it on the graduate side of life?
It's fun. It's pretty slow.
Yeah.
I don't have a lot of deadlines every week.
Yeah. I was gonna say that's probably a big difference now.
And I found out that there is still a lot to learn in this project. I had the luck to come with some experienced co-workers that they teach me a lot. There's still a lot to learn.
Lot to learn. Really great point. But I mean, that's kind of the nice part, is that there's always something to learn, but at the same time, it is nice not to have the deadlines. So,
Especially for this topic, because I feel like this is what we went over the least in the course. So I feel like I was able to learn a lot.
That was going to be my next question, is that I know you guys as a team, like this is not your first rodeo, or code pudding. I guess you're not doing many rodeos if you're doing code puddings, but all the same, how was it this time around? Because I know that when we were doing our briefing, the data set was way different. Yeah, Alfonso, you had many questions.
Oh no, I was just gonna say I'm a graduate too.
You're a graduate too now?
Yeah, yeah.
Yeah.
Oh, congratulations. I'm so
Thank
sorry
you.
to know that. Well, how's graduate life for you now on the other side?
Like Eli mentioned, it's slow. It
It's
just
slow. Yeah.
yeah.
Yeah. You go from warp speed to no speed at all once you graduate. Yeah, for sure. Well, congratulations. Well, how was the code putting with the idea that this code, not code, this data set and what we were asking for you guys to kind of work through was, like Eli said, kind of above and beyond what the normal coursework is.
Yeah.
Yeah,
Also,
the project that we did in the course was a lot of fill in the blanks. Sorry.
No, you're good. Keep talking, man.
So it was really new and different to do it all on our own because one was like, hey, type this in and it works. But this one we had to do it ourselves, so it was really cool to do that.
and also, just from my perspective, this is like the first time ever building like a project like this from scratch until like an actual model that can predict something. So I know
Yeah.
we like Eli was saying, it was we had pieces, we had a structure to just kind of just go off by, but this is something different. We're just basically out in the wilderness, and we had to find a way to make it. Essentially, I mean that's the analogy I'll use.
Yeah, I think that is a really great point to bring up. I know in the software engineering program, that is something that is similar, is that there's a lot of parts where in the software engineering program you have to kind of build it from scratch, but it's very structured, and it's only when you get into these kind of unstructured greenfield start from scratch projects that you're looking at it and you're like, wait, okay, I don't think I remember how to do anything, and you have to kind of get going before you remember, oh, I do know what I'm doing.
Yeah. That's how I had like, because I'm on Sprint 14 right now, and that's what will be using. But they end up like Eli end up using text blob, and I have never heard about it. And so I just understood like so wrong until he explained me what it really means. And like after we started the project, I was trying to, I didn't wanted to use his code, and I was trying my own. But then I got to a point where I end up like using his, because that was the only function in between where we are making like a sentiment feature using text block. But I couldn't find a way, and I end up asking him that is there any other way where I can make text like sentiment feature without using text blob, and he was like, no, that's like many codes you have to write. And I was like, okay. So that's why I was like struggling. And then I end up using his, and then I went to the model part. So it was
Yeah, I
like,
think
yeah,
that's
really
another difference in this code putting situation versus in the coursework. In the coursework, you're not that you're not supposed to ask for answers from other friends, but obviously you're more individually tracked, right? And you're working on your project. And so a little help is one thing, but like asking straight out, like, hey, can I use your code block? Pretty frowned upon. But in this situation, it's like work. If Eli's got a code block that works, I'm not going to go and recreate the lake. I'm just going to go ahead and start fishing. So, all right. Well, I really appreciate you guys taking the time to answer all of my silly questions, especially around the polarity. I did appreciate the graphs that you guys had in both around the polarity. I think that for me, coming from a different lens, is something that I was most surprised about. I thought there was going to be a large kind of correlation in polarity between comments and the amount of likes. And it turns out kids just out there throwing out likes like it's raining. It's just, I don't know what to tell you. Likes mean nothing. So, all right, that was the Sentiment Squad. That was Eli Adams, Alfonso Houston, Gil Fadu, and Laura Cofino. And that is wrapping us up for tonight. So from all of us here at TripleTen, this has been our April DS code putting presentation. Thank you so much for watching. Don't forget to like this video, since we've learned that it apparently means nothing, but should mean something. So Thank you so much. Make sure you vote for your audience favorite after this, either in the Discord if you're a student or in the comments, which we will be scanning later with our learning models that we've just created. And so please make sure you also tune in for results. We will have those posted in our Discord and socials on April 17th. I want to send a special thanks to everyone who helped organize the code putting in the behind the scenes. Daniel, Camillo, Alyssa, Elena, Olivia, Dennis, Anastasia, and of course, the biggest contributor of all, my cat Sharkbait. Thank you again for all of you participating. It takes a lot of courage to work on top of the work you're already doing. And so I really appreciate you taking the time to teach each other, but also help yourself grow. My name is Tiffany Hall. You can find me at Tiffany Codes on Instagram, and you could probably find my cat sitting on top of the refrigerator because cat. Thanks so much and have a great night.